Here we're going to talk about logical statements, negations, and quantified statements and what that means. So before we get into specifics, we have to look at what statement is in general. A statement is a declaration that is true or false, but not both at the same time. So meaning when you say something, you've got a 50-50 chance, or basically two choices. What you said is either true or what you said is false. You can't be both true and false at the same time. However, if we're talking about a mathematical statement, well, there things are a little different, because a mathematical statement is either true or false. Now it seems like those two sentences are the same. Okay, true or false but not the same, whereas a mathematical sentence is either true or false. But there are slight differences there, and they're very minor, and that's some of what we're going to be looking at through the course of a couple examples. Now, another thing we have to take into account is a paradox. A paradox is a sentence that's going to contradict itself. For example, it may start out by being truthful, but at the end it becomes false, or meaning whatever you said in the beginning, you totally unravel with what you've said at the end. A paradox cannot be a mathematical statement, because a paradox has both truth and false to it. So for a lot of these, usually what happens is you're given a sentence and you're just simply asked if it's a mathematical statement or not. So you need to remember, a mathematical statement is either 100% true or 100% false. So here this first one says, the car in front of me is turning around. Well, if you look at that sentence, when you start in the beginning, we're talking about a car in front of you, and we're talking about the fact that it's turning around. Therefore, that could be completely true, or it can be completely false. Since it follows the definition of a mathematical statement, we would say that it would be yes, or you would list this as true. Now, the next one, running is fun. Well, there's not enough context there for you to really call that a statement. And so therefore, in this case, we would have to say false. The one after that says, get out of my room. Now when we look at that statement again, we cannot determine whether it's all true or all false. There's not enough context to the statement to make a decision. Since you cannot decide or come to a conclusion that it's either all true or all false, you would have to call this false. The last one says, either we are going to the beach or the mountains for vacation this year. When we look at this sentence, we can see that this sentence is all true or it's all false. It's giving you the option of where you might be going for vacation this year. Therefore, this one we would be able to say could represent a mathematical statement. Now, when we look at negations, a negation is where we're talking about the opposite of a statement. Okay, meaning if your original statement was true, a negation would be false, and vice versa. We have these symbols here, so each of these symbols looks a little bit different, and all three of them mean negation. And we use these symbols, say, in front of our variables, and they help us with writing a mathematical sentence or statement involving the negation. So here, what we're presented with is we're presented with a statement, like this one, today is sunny. And you need to write the negation. So for here, today is sunny, we have two options for how the negation could look. First, we could say, today is not sunny. Or we could say today is cloudy. Both of these versions are a negation of the sentence that was given. Today is sunny. Both of these represent the idea that we are writing the opposite of the statement given. This first statement here, today is not sunny, is the preferred statement that we would usually use. However, in English, we would have said today is cloudy or today is rainy. So you kind of have your choice, but I want to err you on the side of caution that most of the time we are talking about just go ahead and using the exact opposite, which would be usually to input the word not. Now the second one's a little bit more challenging here. It says 329 people applied for the same job I did. So for here, we would simply be able to say that 329 is not the number of people that applied for the same job I did. That's just one version of a sentence you could make. Again, notice all we simply did was we took the statement that was given and we turned it into a negation. Now with negations, we have what are called negation quantifiers. A quantifier is a word, such as all, some, none, or no, that shows up inside a statement, and it helps you figure out what the negation might be. Okay? What that means is that you can't just simply put the word not in front of all quantifiers to negate it. You have to use some semblance of the English language to make these things correct. Okay? In other words, we actually want to get the true opposite of that original statement. Therefore, we have quantifiers that help us figure out what the true opposite might be. So for example, if we see the quantifier all are, then when we write the negation, we have to include not all are, some are not, at least one is not. Now you would decide which of these quantifiers is going to work depending on the sentence you were given. Again, the quantifier is going to be from the given sentence. Okay, so this right here is from the given statement. Some are, the opposite would be none are. Some are not, the opposite all are. None are, the opposite might be some are, there is at least one that is. So here are some examples. Again, you will be given the same thing. You will be given a sentence or a statement, and you have to use the appropriate negation quantifiers in order to properly write the sentence. So we have the door is not open. Okay, so here what would happen is we would have the negation that would say the door is not open, which we all know to be the double negative in the English language, but when we're talking about a math statement, that's not necessarily a horrible thing. What we're doing is we are negating the sentence that we see. So not open is our negation. Now, obviously the other thing that we could see or say would be the door is closed. Again, we all know the opposite of open is closed, and so to say that the door is closed would be a negation. Now here we have none of the Christmas tree lights are not working. So here we have are not. So when we're looking at that, we need to negate it. So we would say at least one of the Christmas lights is not working. The last one says all summer days are sunny. And so here we would end up saying not all the summer days are sunny. So those are just 3 examples of being able to take a statement and being able to rewrite it using the proper negation quantifier. So I hope you enjoyed this little mini lesson on what it means to have logic statements, negations, and quantifiers. If you have any questions, please let me know. If you have any examples that you would like to see or need help with beyond these ones we talked about, please let me know those too, and I would be happy to answer any of those questions and go over any of those examples. Otherwise, I do hope you enjoyed yourself, and I look forward to talking with you next time.